So if we have pure reactants, the reaction is going to be spontaneous in the forward direction. So we'll have a reaction that is spontaneous in the forward direction. And what will that mean about our friend delta G? Is it going to be greater or less than 0? So it'll be less than 0. So delta G of the forward reaction will be less than 0. So when delta G is negative, the reaction is spontaneous in the forward direction. So what about when you have pure products? Then the reaction should be spontaneous in the reverse direction. So you have spontaneous in the reverse direction. And what does that mean about the sign of delta G? Greater and less than 0? Greater. So it'll be positive. So we can think about that in terms of a plot. We can think about free energy versus the progress of the reaction. So the progress of the reaction is going this direction as you go along. So in the beginning, if you have pure reactants, delta G is going to be less than 0. And you're going to proceed along in the forward direction spontaneously. If, on the other hand, you have pure products, delta G will be positive, so you'll be spontaneous in the reverse direction, and the reaction will go in the reverse direction until what happens? Till you reach equilibrium. And what would delta G be at equilibrium? 0. Right. So you see, there is a great relationship between delta G and equilibrium. So we have not left delta G behind. So delta G is going to change as the components of the reaction change. As you have more products or more reactants, you're going to have a different delta G.